Hello and welcome to this demo of the Buggy Randomizer. I'll be walking through some pretty intricate examples of the different ways that you can actually use this application, but before we even get into that, I want to introduce what Buggy is in the first place and why a schedule randomizer might actually help you with some of the tasks that come along with Buggy. I'm going to do this through my fraternity's website because I actually created the randomizer for my fraternity for some of the challenges that we face, which I'll get into in a second. But Buggy has been a major part of my fraternity's history and is the longest standing tradition at Carnegie Mellon. So without further ado, let's actually look at what Buggy is. This is Buggy. Essentially, Buggy is a race between different teams who are pushing small carbon fiber capsules. As for Buggy in the context of my fraternity and why I actually decided to build a randomizer for it, we can look at some of the timeline and see how big of an impact it actually has had on our fraternity over the years. Our fraternity dates back very far. As you can see, it actually ends up dating back all the way to 1922. But since we joined the Buggy League at Carnegie Mellon, we have been the most successful team in history, achieving first place countless times. Actually, I think the stats were over at the top here. Yeah, so it looks like we have 133 trophies, which is placing either first, second, or third. And then we actually have 29 wins, which is more than any team at Carnegie Mellon, and 11 women championships. Down here are beloved buggies, and while you're taking a look at some of the different buggies and different members that we have in our fraternity, I'll just tell you why it's so important to have a randomizer. One thing about Buggy is that it takes place on popular roads around Carnegie Mellon, which cars need to drive on. The issue with that is that you can't do it during the middle of the day when it's going to cause a massive traffic block. Usually Buggy actually takes place at very early times in the morning and when most people are free, which is on the weekends. Oftentimes Buggy is at Saturday at 5 a.m. or Sunday at 5 a.m., which can make getting up for practice a little bit difficult and something that not everyone wants to do every weekend. However, we do need our drivers to practice and we do need our team to improve. We need people to come out every weekend. Back to our randomizer. This randomizer creates a randomized schedule for Buggy based on a series of inputs so that people are not actually having to manually pick the schedule and biases cannot be applied in any way. When I took over as president of the fraternity in 2021, this was my first project I wanted to introduce to the chapter because I had seen this as such a major issue in the past, which caused lots of conflicts between members. Without further ado, let's look at some of the inputs so we can get a better understanding of how this actually creates a random schedule. First off, at the top, we have exemptions. For example, if I wasn't going to be able to make it this weekend, I could just add my name here and this would take me out of the schedule for that week while still randomizing the schedule for everyone else. Moving on to the next section, guaranteed. Let's say, for instance, I missed 3 weekends in a row because I was out of town or I had some sort of homework assignment due. Then I might have agreed upon the fact that in the future I would be guaranteed to go to one of these buggies since I was exempt from the past few. If I automatically want to be included in the schedule or you automatically want to include multiple people in the schedule, let's say we include myself and perhaps some other person in my fraternity such as SpongeBob. SpongeBob is not actually in my fraternity, but I'm using cartoon characters for the sake of this example. So SpongeBob and I would be guaranteed to be in the schedule somewhere while the rest of the required positions are decided by the randomizer. Moving on to the next section, we have positions which are pushers, flaggers, videos and timers, bails, barricaders, and backups. I'll quickly explain each one. Don't worry too much about the details. Pushers are the ones who actually push the buggies. Flaggers are people who stand on the track holding flags, and it's hard to see from actually being inside the buggy, so they help direct the buggy drivers to the right locations on the track. Video and timers are just the ones who video the runs of the buggy and take down the lap times for analysis. As for bails, we want to make sure we're keeping our buggy drivers safe, so we set up hay bales along the curbs of the sidewalk since the buggies actually go pretty fast. And this often requires a lot of people because you do have to set up hundreds of bales on the areas that could be especially risky for buggy drivers. Barricaders serve a similar task except they're there in the morning. Backups are people who don't actually have a position but should be ready to fill in for people assigned to the schedule should a last-minute event come up. The reason I've implemented these positions as sliders is because you can just select the amount of required people for that position for that week, which oftentimes changes. Looking over to the right, we have different probabilities by seniority. Since juniors and seniors have potentially busier schedules throughout the semester, they are often assigned slightly lower probabilities than freshmen and sophomores who are more available. Also, if there's a particular class that enjoys Buggy a lot more, they'll be assigned a higher probability. Other examples would be when an entire class is out of town, you can just set that probability to 0 instead of putting them all in exempt. Or if you want to assign a specific class to a specific position, but need to choose among those members, say for example, there is 12 people in the sophomore class and you need 4 people on bails, you can put this at 4, put the rest of the probabilities over at 0, and then put this at 100 or 1 or whatever. It doesn't matter, these probabilities are actually normalized in the program. Again, if you have 10 here, that would just be a 10 out of 14 chance of any given sophomore being selected, and then a 1 out of 14 chance for the remaining classes. The last feature I'd like to talk about here is the select by groups. It's small down at the bottom of the screen, but it is mighty. I am most proud of this feature just because it's a really innovative way of getting people to show up on time and actually be able to enjoy themselves. In terms of functionality, you can just toggle it off and on. It's defaulted to on at this point because our fraternity has found a lot of success in using it. A lot of times when schedules were assigned, even with all sorts of randomization processes, it never really worked well because people were being selected from different friend groups within our fraternity or who lived in far different locations, so people had trouble getting rides and might need to wake up at 5 a.m. and walk 30 minutes to get to the Buggy course. What Select by Group does is it allows you to group members together who have similarities, such as a similar friend group or have a similar living location. When someone is selected from that group, these groups are all selected together, and it's still completely random. Say I'm living with 4 different people, and it's about a 10-minute drive from the Buggy course. Then if one of my housemates is selected, then I will be selected too, and so will the rest of my housemates. And this ensures that we'll all be able to get up together, find a ride together, and make sure to wake each other up in case anyone's extra tired. The probability of any individual group being selected is actually the total probability of any one of the members being selected individually as compared to all of the other groups. And then if someone's not assigned into a group, the probability of that group being selected is just the same probability of them being selected individually. Awesome. So I think we have a great introduction of what the actual purpose of the randomizer is, but I'd like you to get a sense of the implementation, and then I'd love to show it in action. Popping over to our coding window here, we have several different files, the main one being the Buggy randomizer. I want to say that I represented myself well in implementing this project, even though it's not the most complex application. It'll allow you to get a sense of my programming style, some of the skills, my documentation, modularity. Feel free to check it out on GitHub. The Buggy randomizer itself is implemented as a class using tkinter. Up here, we just have some initializations, followed by helpers for initializations, a couple of general purpose functions, and then we move down to our validation, which has robust error checking, making sure that the user cannot break the program no matter what they enter. A few more helpers for those validation processes. Then finally, we get down to our actual randomization logic. The selection is obviously quite simple here. All we do is use some of the Python built-in modules. The select by group function is a little bit more complex, but utilizes the same basic principles for selecting by group and then for selecting by individual within the group. All of this is encapsulated within our main function, which is execute the randomization program. What you've yet to see beyond the initial screen is the animations that I've added that are what make this app a hit in my fraternity and why I've provided the code base to other fraternities and now posted it publicly for it to be used across all of Carnegie Mellon, which is the custom choices modal library, which I implemented and serves the same purpose as any plain old modal, lays a screen over the top of the initial canvas, which features a series of animations and then the ability to generate a Word document of the schedule and email it out to anyone you want. If we take a look at the implementation, we set up our initial screen. We have the ability to resize and crop images, which we work with directly, which I'll show you in a second. Then we have our spin animation, which spins between the different images, generating a random choice effect. We also have some functions to help display the current running lists of selected people. We then display the final lists, then have a function which uses another custom module I created called schedule documents, which allows you to actually create the schedule document and then email it out, as I said, to anyone that you want. So we can take a look at that file now. This is a simple module which uses several helper functions just to validate the different inputs, work with date time, and actually compile the documents. And the reason I say documents is because it actually compiles 2 different documents, one for a subsection of the schedule called bales, which takes place actually at night, and then rolls, which is what I was mostly referring to earlier, which takes place early in the morning. Using those helpers, we simply create our file, and then finally we're able to email that out using a simple SMTP, obviously hiding my fraternity's password and email using environment variables. This is a great introduction of the implementation, so now let's take a look at how you can actually use this. Here we're looking at constants.py, which is the file that you change to modify the program year by year to add different members. Obviously this has limitations, but I was writing this quickly and also didn't want to put my card down for an indefinite period of time in order to maintain the program. So here we are. We have our different positions as lists of image files, which are utilized in the animations. I decided to use cartoon characters because I thought it would be a great demonstration. I ordered the cartoon characters by the date that they were created, so you can see the more modern characters such as Elsa from Frozen or Among Us or Elastigirl are in the freshman category. Next comes Mike Wazowski, Sully, Shrek. A bit earlier than that was SpongeBob and Lisa Simpson. And then way back in the past was the Grinch, Tweety, and Clifford. Tweety is actually the oldest cartoon character in this program, so is going to act as the BN, or the Buggy Navigator, which is the person who heads our Buggy program. As for groups, I decided to group them by colors. You can see that Elastigirl, Clifford, and Among Us are in red. Similarly, Smurfette, Dory, Elsa, etc. Those are in blue, and then we have yellow and green. And then just for the sake of demonstrating that you actually don't need to put everyone into a group, I left Patrick from SpongeBob not in a group. I also up here left the new member section open just to show that we can have empty seniorities. Let's run our program and see how it works. I highly suggest that you try this on your own as well. It's a pretty fun program to use, even if it's not for the purpose of Buggy. The README pretty clearly defines how you can install and run it on your local device. Again, take a look at the GitHub repository, which should be attached as a link in this video, or you can go to my GitHub, github.com/ConnorMoss. Without further ado, let's say, for example, Patrick has missed 10 buggies in a row, and we need him to go to this buggy. Let's say the freshmen are not able to attend this specific buggy, so we make their probability 0. Let's leave the rest of the probabilities equal here. We need 3 pushers, we need at least 1 video and timer, and then we don't need anyone on our bales. For simplicity, and just to show the animations, let's turn off select groups and just see who it selects. We can see Tweety up here in the right corner as our Buggy Navigator. This is our spinning animation, which maps people to their position and then updates the running lists here at the top. It looks like Patrick is in our list at some point. He was in our guaranteed. The rest should be random. And we also should get no one in our freshman class. We had Among Us, Elsa, Chick, and Elastigirl, and it looks like Tweety, Grinch, Patrick, and Smurfette, and Lisa are in our list, all of which do not fall into our freshman category. Right now, we can either restart the program or we can email out our schedule. Let's save the email part for later and run it a few more times to see what other results we can get. Let's say Patrick is applying to new jobs this weekend and won't have time to make buggies. So we'll add Patrick to exempt. Now we only have groups remaining. Let's make sure our randomizer selects by group when the select by group button is on, so characters of the same color end up being able to go to buggy together. Let's say for this specific buggy, we need 2 pushers, 1 flagger, and we don't need any video and timers this time, but these people are unreliable, so we want 3 backups. We also need 1 person to do bales in the morning. In total here, we have a required amount of 7 people. Let's run it. A quick feature I want to point out while these animations are running is that you can click this finish animation button here, which should stop the animations early. Looks like we're generating both red and green, as we've gotten Shrek, Among Us, Elastigirl, Grinch. All of these fall into either the red or green category. As you can see, our program worked effectively. We only have red and green in these categories. We have Elastigirl, who is red, Among Us, red, Clifford, red. For flaggers, we have Shrek, who's green, Grinch, green, Chick, green. All of the green people get to wake up together. Say the green people, for example, live together, and then the red people get to wake up together, which is a really nice thing, and it was selected completely randomly out of those remaining groups. Now that we've kind of seen the different functionality, let's try to break our program. We only have 14 different characters. Let's try to assign these 14 different characters to 20 positions. As you can see, it's not going to allow us to do that because there's not enough characters to fill the positions. Let's try to run the program without assigning any positions at all. We need to choose at least 1 position to fill. Let's try to exempt Tweety. Note that Tweety's exempted here because he's the Buggy Navigator, which shows up to Buggy anyway, so we don't want him to be selected in the schedule. But for the sake of example, we want him to be in the guaranteed list. You can't be exempt and you can't be guaranteed. That doesn't make any sense. Bring up the proper error there. Let's say that we want to assign positions, but everyone's probability is set to 0, and maybe even senior is set to -1. When we try to run it, we see that we must have 1 probability that's greater than or equal to 0. Let's restart. We can also try to break it by giving it unknown names. Someone that we haven't seen is Homer Simpson. We'll type in Homer and try to run the program from guaranteed, but Homer's an unknown name in our list. Now that we've seen the main functionality of selection by groups and selection not by groups and the different error handling methods that the application is equipped with, we're going to look at the automated schedule document creation and emailing process that this application enables. To illustrate this in a robust manner, I want to use as many characters as possible to fill positions. For the sake of this, I'm going to take Tweety off of our exemptions list and use him as one of our positions. Pushers are super important, so we might do 7 pushers. We need at least 2 flaggers. Video and timers are for improvement, so we'll add 1 for that. We don't really have much room for backups, so we won't add any backups. As for barricaders, 1 should probably do, and then we'll put the remaining 3 people up for bales. However, just to illustrate that backups will show up on our document, we'll take off 1 for bales and then add 1 backup. Since this is selecting everyone, we can turn the select by groups off. We can make use of the finish animation button. As we can see from our results here, Tweety should be the buggy navigator, but also assigned to a position. We should have 7 pushers, which we do, 1 backup, 1 barricader, 2 people on bales, and 1 video end timer. This worked as expected, so let's get into the actual emailing process behind this application. So we don't have to go back to it later, and to emphasize the robustness and error handling of this program, let's try to break it using the different fields for sending a schedule. First, we can try adding nonsense to the buggy date. As you can see here, we get an error pop-up asking us to enter a valid future date in the form MMDDYY. Maybe we can try entering numbers though, because that might work. However, we still receive the same error. But let's try to mimic the format that it's asking for, but not actually put numbers. As you can see, it's still bringing up this error. Perhaps our final try could be creating some fake date, which would be maybe the 10th of October in 1999, which wouldn't exist for Buggy at this point since it's 2023. It looks like we still need to enter the valid future date in this format. So knowing that we can't break it, let's enter a real date, perhaps for this weekend, which would be the 21st of October of 2023, to put my actual email in there, and then we can check my inbox after. And we send it. After sending it, we get a pop-up that says the email was successfully sent. At this point, we have nothing more to do with our program, so we can either restart it, or we can go up to our top here and just completely close out the program, which quits it safely no matter where you're executing it. Something that I haven't mentioned yet that you might have noticed is this folder called Past. Past is super helpful because it stores all of the documents that it sent over email within the folder, just in case it gets lost somewhere along in the email chain, it goes to spam, it gets deleted, or you just want to look at who was assigned roles and bales for the past few weeks. Remember, I mentioned that it creates 2 different documents, one for bales and one for rolls. Bales is at night, so 10/20 is the day before, which is Friday, and then rolls is the morning of, which is 10/21. So the dates are correct for both of those files, and those should have both be emailed out to my inbox by now. If we take a look at my inbox, we see we got an email from Pico Racing, and attached are 2 docs. Let's take a look at them. We only assigned 2 people to bales, which is pretty unrealistic, but our document simply lists the people who are set up for bales, which is just Shrek and Chick Hicks. Also, you can see that the title and the date is displayed, as well as the day of the week. As for the roles document, it's much more detailed. It has all of the different sections here, from barricaders down to flaggers, the 7 pushers that we assigned. Also, notice at the top here that we have our weekday set as Saturday. So something actually really nice about automated schedule doc creation is that it also randomizes the process of assigning people to hills. In Buggy, the course is composed of uphills and downhills. There are 4 main locations that pushers push from, which are referred to as these hills. Some of the hills are much easier than other hills, so there's often conflict between who gets what hill. It's nice to have a process that completely randomizes which hill you're actually assigned to. You'll notice that not only does it assign pushers to hills, but it also distributes it equally. Obviously, you can't equally distribute 7 pushers to 4 hills, but it does its best, assigning 2 to hills 1 through 3, and then 1 person to hill 4. Finally, at the end of our doc, we have a general schedule attached. Very helpful because people often forget it, as there's a lot going on in a very short amount of time. This sadly concludes the Buggy Randomizer demo. If you've made it this far, I really hope you did enjoy my explanation and thought process behind the implementation. I'm no longer developing this and leaving it to future generations to improve upon the app, but I'm proud to be the person to generate the idea and have established it as such a success within my fraternity, soon to be other fraternities, and hopefully as a Buggy-wide tool down the road. Again, thank you for watching. This concludes the demo.